Today we're going to talk about how we reflect functions and what effect a reflection will have on a parent graph. And so we're going to start with comparing the functions of the form y equals f of x and y equals negative f of x. So the first thing I'd like you to do is recall what happens to my quadratic graph when I go from y equals x squared to y equals negative x squared. This should be pretty easy because you should know that this is your a value, right? And in this case, a is -1. And so all that happens is that it's going to be reflected. This one opens up and this one opens down. And I hope that when you look at that, first thing that comes to your mind, oh yeah, okay, a is negative, so it opens down. So we have that example here, y equals x squared. The first thing we're going to do is graph the parent graph. So there, again, I apologize for my not very good lines. It's a problem with the program. So there we have our parent graph, y equals x squared. So what is the domain and what is the range of our parent graph? Domain, right, goes this way. So remember, stop and think. Is there anything that is going to stop or cause a restriction on my x value? Of course, the answer to that is 0, meaning there is no restrictions. So x is in the real family with no restrictions. So it's just x is in the real family, and that is my domain. But as you can see, my range does have a restriction because the y value never goes below 0. So that's going to be my range restriction. Now let's graph the reflected graph of y equals x squared. So y equals negative x squared. So when I have y equals negative x squared, it takes every single point that used to be above the x-axis and it maps it below the x-axis. Sorry, it maps the y values below the x-axis. Notice how the x values don't change. The y value is what gets mapped below the x-axis. Or the y value gets reflected to its negative. Now because a reflection, this kind of a reflection, only impacts the y value, my domain is going to have no change in this case. So my domain is still going to be x is in the real family, but my range is now y has to be anything that is less than or equal to 0. So let's look at a new parent graph. We've got y equals the square root of x minus 1. Well, if you recall from when we looked at our horizontal and vertical translations, this is an inferred bracket inside the square root sign, which means that this is going to be translated to the right because we always translate to the opposite direction of the sign that is inside a bracket with an x. So we're going to translate this to the right, 1. So we're going to take our parent graph, which normally would be right like so. As you can see, we've got the square root of x, the normal parent graph of square root of x, translated to the right one for the parent graph on this particular example to be the y equals the square root of x minus 1. And also notice that we now have both domain and range restrictions, since there's a restriction on what our x value can be, and there's restrictions on what the y value can be. Now let's reflect this graph in this format. So now we want it to be y equals negative the square root of x minus 1. So now the y values are reflected across the x-axis, or they become negative, and the x values stay the same. So there's our reflected graph. Note that our domain doesn't change because x is still has to be greater than or equal to 1, but our range does now change because now our y values are all below the x-axis, so y now has to be less than or equal to 0. So some summary questions here. Which axis were all the above equations reflected in? And if you recall, they were all reflected across the x-axis. And that the points that were unchanged in the reflection were the x values. It was only the y values that were changing. So there's a new definition here for you. Points that remain unchanged in a transformation are said to be the invariant points. So when you think to yourself, which points didn't change? It would be the points that were on the x-axis. The unchanged points were found on the x-axis. Now, the only reason that all of these points that were on the x-axis is because we did not move this graph up or down. So the unchanged points are actually the points that are on the axis of reflection. So this may seem like a fine point of difference, but it's an important point of difference because now we're going to look at comparing graphs. Instead of y equals negative f of x, we're going to look at reflecting them y equals f of negative x. So just for a second, I'd love you to stop and think about what point is now having the negative impact. So first, we're going to draw our parent graph, y equals 2 to the exponent x. Now remember, when we have an exponential equation, we have an asymptote, and the asymptote in this case is the x-axis. So we have no restrictions on what our domain can be. Domain can be anything. Our range, though, y must be greater than 0. It never touches 0. So let's think about what our reflected graph is going to look like. Remember, this is not negative 2 to the exponent x, which would be reflected across the x-axis. Now we're looking at positive 2 to the exponent negative x. Well, what happens when I have a negative exponent? I take the reciprocal of the base and I make the exponent positive. So now, if we just do a quick little table of values, if you want, over here. So what's x, what's y? Okay, so when x is, let's start with a value of 3. So when x is 3, what is 2 to the exponent negative 3? Well, it's 1 over 2 to the exponent 3, which is 1 over 8. What happens when x is 2? Well, it's 1 over 2 squared, which is now going to be a quarter. What happens when it's 1? Well, now it's 2 to the exponent negative 1, which is a half. And 0, anything raised to the exponent 0 is 1. Now, 2 to the negative 1, right? So now what's a double negative? Negative times a negative is a positive. So now 2 raised to the exponent negative 1 of a negative 1 is going to be positive 2. Negative 2 is going to be positive 4. Negative 3 is going to be positive 8. So let's graph that. So note this time, where am I reflecting? Where am I reflecting around? Last time it would have gone from being pointing in this direction, and it would have gone down that way. That would have been y is negative 2 to the exponent x. Okay, that's what we did on the last page. So just keep track of the difference. Now we're going to do our domain and range again. Once again, my domain doesn't change. I can have any value of r in the real family. That could be x. In this case, my y value also doesn't change. My range doesn't change. My range is still, y just has to be greater than 0 because my asymptote is still 0. So let's look at a nice easy graph, y equals x plus 2. I hope you can identify that that's a nice easy graph because that's a line. That's a line, that's y equals mx plus b format. So now we just have to graph a line that has a slope of 1 and a y-intercept of 2. And again, my apologies for not being able to draw a straight line with this program. So let's state our domain and range. Is there any restriction on what x can be? No. Is there any restriction on what y can be? No. So what happens when I make the x negative? Well, what happens is I now have a negative slope of negative 1 instead of a slope of positive 1. And once again, I have no restrictions on what x or y can be, so my domain and range don't change. So when you look at this, what axis have I been reflected across? Well, I hope you notice that we've been reflecting it across the y-axis this time instead of the x-axis. And the invariant points, once again, are on the axis of reflection, which in this case was the y-axis, right? But just remember, it is the axis of reflection, because if we had moved this graph around some more, then it wouldn't necessarily be the y-axis. So we can make a few conclusions. We can conclude that graphs of f of negative x, functions of negative x, is a reflection of the graph f of x in the y-axis. And the graph of negative f of x is a reflection of the graph of f of x in the x-axis. So a graph of negative f of negative x would be a reflection of the graph f of x in both the y and the x-axis. So we're going to do one last graph example. So we're going to state the domain and range of each function, and we're going to graph each of these functions. So let's have a look at this function that they've given us. It is f of x equal to the square root of x plus 1. Note, the plus 1 is not underneath the square root sign, which means that that is a vertical translation up, not a horizontal translation to the left. So here is the parent graph in this case. So there's our domain and range for that function. X has got to be greater than or equal to 0, and y has to be greater than or equal to 1. So let's look at a reflection in the y-axis. Okay, so if h of x is a reflection in the y-axis, it means that h of x is equal to f of negative x. So the reflection in the y-axis means we're going to flip the graph that way to reflect it across the y-axis. So there's our reflected across the y-axis graph. Don't panic that there's a negative inside the square root sign. That's why all the numbers must be negative, because when you multiply negative by a negative, you get a positive, and then we can take the square root. So that's why it's reflected across the y-axis, and that's why we have points that can go into that function. And when we reflect across the y-axis, it is the x values that are being impacted, not the y values, so our range doesn't change. So now we're going to use a different color, and we're going to reflect this across the x-axis. Okay, so now it's the x values that are going to become negative, and the y values are going to stay the same. So there we have it. There's your new graph in red. And remember that a reflection in the x-axis is the same, a different way to say that is to say r of x equals negative f of x. So there's my domain and range. My domain has to be greater than or equal to 0, which is same as the parent graph. And because remember that when I reflect it across the x-axis, it is my range. Sorry, my range changes. My domain does not. So my range, I now have to be less than or equal to 1. So last but not least, we're going to have a reflection in both the x and the y-axis, which means that now both the x and the y are going to become negative. So using function notation, s of x is equal to negative f of negative x. That's how we would say that. And so here's the equation. S of x is equal to negative the square root of negative x plus 1. And so, as you can see, now both my domain and range are going to be the opposite from where I started. So for these last few examples, determine the equation for g of x. I'm going to have you do those ones on your own. Those would be on a homework sheet for you. So you can pause the video, write those down, give them a try.